Good afternoon, everyone. Now let us start our paper presentation. Here will be track one. Track one will be held here, and the topic is language, technology, and linguistics. Before starting the paper presentation, I would like to introduce our session chairs, Dr. Premjit Sir and Dr. Bala Subramaniam Sir. Dr. Premjit Sir is an assistant professor at Center of Computational Engineering and Networking, Amrita Vishwavidyapeetham, Coimbatore. And Dr. Bala Subramaniam Sir is an assistant professor in the School of Computational Science and Engineering, Kerala University of Digital Science. And we welcome you, sir, for the sessions. Now I'll be telling the guidelines for the paper presentation. Attention all, I'll be sharing the guidelines. For the paper presentation, length will be 20 minutes and 15 minutes will be for the presentation and the remaining 5 minutes for the question answer session and the discussion. At the start, there will be a buzzer, and after buzzering, you can start your presentation. And after 10 minutes, there will be a sign shown that is 5 minutes left. And after 15 minutes, the second buzzer will be heard, and you can stop your presentation. And next will be the question answering section. So total 20 minutes for the complete presentation and 15 minutes for presentation and 5 minutes for the question answering. Is it clear for everyone? 15 minutes for the presentation and 5 minutes for the question answering. And there will be a buzzer at the start, and after 15 minutes, you have to end the presentation. Okay. The first paper of the track one will be on the topic domain-specific token recognition using bidirectional encoder representations from transformers and Skybird. Nisha Varghese, ma'am, is it audible?
Yes, it's audible. I'm on.
Okay, you can start the presentation.
Shall I share my screen?
After the buzzer, you can start your presentation.
My screen is visible or not?
Yes, ma'am, it is visible.
Okay. Thank you. Good afternoon. Myself, I am Nisha Varghese, and my co-author is Shafi Sharif. Our topic is domain-specific token recognition using the bidirectional encoder representation from transformers and SEI BERT. The contents inside the slides are introduction, literature review, methodology, results, conclusion and future enhancement, references. In the introduction part, making machines to read the comprehend information from our natural language documents is not an easy thing. So the feature extraction from a document is a complex thing. So what we have to do with the traditional rule-based models and other machine learning traditional approaches of machine learning, deep learning approaches, what it is doing. So to overcome the limitations of this feature extraction and the understanding of a specific word with different models, here the methodology it is using the transformer-based methodologies. Specifically in this study and this research article included the transformer-based models and in that BERT-based models, bidirectional encoder representation from transformer models. So this is like a comparative study to identify the tokens, how it is working in the BERT and as well as the SEI BERT. So for the literature review analysis purpose, I have selected the three models only. The first one is the domain-specific model, SEA-BERT, and second one is the bio-BERT. Third one is the clinical BERT. And SEA-BERT is a combined area of biomedical and computer science, and it is pre-trained based on the scientific article that is taken from the Semantic Scholar, and it is textual size is approximately 1.14 million. And second one is the biobird, and that also it is a biomedical domain article which is pre-trained with the biomedical data set that also taken from the PubMed and PubMed Central data, and it is trained for really 3 days of NVIDIA GPU capability. And then the final one is the clinical BERT. A clinical BERT is which is pre-trained using the clinical notes, and that also the combined version of the bioclinical BERT and biodischarge summary of the BERT model. These three models I have taken for the literature review purpose. In the methodology section, transformers. Transformers are the an exceptional models that is evolved in 2017 by the Google, and it is developed by Ashish Vashwani. And it is the advantage of this transformers are it is providing the transfer learning, attention mechanism, and parallelization at the same time. And the fully utilization of the transfer learning is one of the advantage. And another technique, it is a model it is used here is a BERT. BERT is a bidirectional encoder representation. It is using completely bidirectional features the first time as a transformer model, and that also providing the transfer learning facilities. This is a pre-trained model, and it is pre-trained with the Wikipedia articles and the Toronto Book Corpus, and approximately 16 GB of data. So how the transformers is a complex architecture which containing the features like transfer learning and parallelization. In components including this transformers are attention mechanism, multi-head attention, positional encoding, fully connected neural network, and final softmax layer. But as based on the transformers, it is developed in 2018, and this is the first bidirectional transformer model. And there are so many versions of BERT also: BERT mini, BERT small, medium, large, and all. And here it is the BERT medium contains the 110 millions of parameters, and it contains 12 layers of deep neural network layers. So it is used with the Toronto Book Corpus and Wikipedia article to train the document. And after the pre-training, we can utilize that pre-trained data for the further fine-tuning task for the tailoring task of the natural language processing, or suppose machine learning, name identity recognition, machine translation, and question answering. That kinds of things we can utilize. The advantage over the machine learning and deep learning, which means if sufficient amount of data is not there also, because of this pre-trained model, it can perform better results with the minimum epochs. That is one of the advantage. And SEA-BERT is this is a comparative study here with how the SEA-BERT and the BERT-based models identifying a token as the comparison is happening. Here, the base vocabulary of the BERT is known as the base vocab, and at the same case, SEA-BERT vocabulary is named as the SEA vocab, and both have approximately 30,000 of words. In that 30,000 of word also, that is 42% of that words are overlapped. The rest of the words are not overlapped. And so we can understand at the time of pre-training, there is a clear-cut distinction between the tokens containing in both of the models. And here it is used as a full-length paper for the pre-training for the SEA-BERT, and the average paper length of that is taken from the Semantic Scholar is 115 for sentence for the token comparison and all. And here it is the performance of SEA-BERT in a specific token, and the same time of that of the BERT model, how it is how clearly it is differentiating. We are analyzing this part. And this is a part of the research of one of my research I included. And here we considered the talker length. Out of approximately, we already discussed that there is 30,000, approximately 30,000 words are there, common words. This is the statistics of how it is, the words are coming like that. And that also containing the number of numeric values are also included there at the time of training. And including all these things, we can see the difference between the BERT vocabulary talker length and at the same time SCA BERT also. And the result part, I incorporated the comparative study of SCA and BERT also. For that, I have took some of the medical terminologies, how it is different from the normal BERT and the SCA BERT. The first one you can see here in the left hand side, it's a dexamethasone. So SCA BERT, it is understood that a specific term without any separation. Subtokens, it is not divided. As per in BERT, you can see the double hash symbol. That double hash symbol is denote that that is a it is a split as a subword. The model is not able to understand that is a full word, so it is divided as a subtoken like that, and only it is understanding. The second one, when we are considering, it is a corticosteroid. That in the corticosteroid also SCA BERT is understanding it in a proper way, and but BERT is again, it is divided into 5 subtokens. And the next word also prednisolone, that is also SCA BERT can understand by as a 2 subtokens, but BERT can understand as a 5 subtokens. The difference between that is the SCI BERT is pre-trained on the scientific computer science. At the same time, biomedical article it is taken and it is pre-trained. In the case of BERT, it is a general data set of Wikipedia articles, and at the same time, Toronto Book Corpus, it is pre-trained. So the machines are learned in a different understand in a comprehensive understanding of these tokens are in different way in the BERT, and at the same time in the SCA BERT also. And according to the statistics of BERT, the tokens contain 3.61 of text, that including the digits and tokens, and the comparison of SCA BERT, it is 10.76% of the all text. And here the comparison it is used, the BERT is used as the world peace model for understanding the tokenization, and SCA BERT is used as a sentence peace model for the tokenization. And it is having the maximum token length of 18 for both the SCA BERT and BERT it is used. So this is the statistics how it is understanding the subwords also, and the tokens in the entire context or data set that they trained also. And one more thing I have incorporated here, based on that understanding, I had took one query as that contains some biomedical terminologies like dexamethasone, corticosteroid, anti-inflammatory, immunosuppressants, something like that. So based on that query, how the other context how it is comparison is for a similarity analysis it is taking. So for the sentence embedding, I have considered that for finding the SCA BERT and BERT, the similarity percentage it is identified. That is also used to understand the sentence embedding, that is SENBERT it is used. And for the first query and along with the first context is 0.93 in SCA BERT, and similarity of a query and the B is 0.91 it is. And the second one, the BERT one, similarity is 0.81, and similarity is 0.69 in the BERT based models. So it is a clear explanation about how the biomedical terminologies, how BERT is understanding, and the understanding. And this is the result I have taken from the implementation. So here it is a lengthy statement in the same context and question what I showed here, that only the same here. So from that, what is the dexamethasone, like that a question I included, that corticosteroid is. So where the answer is starting, where the answer is ending, like that clearly it is mentioned. That is a the same image only. So the answer is starting from here to here, like that is the answer from bird only. Why? Because it is not understanding in as a single word. It is dividing as a five subtokens are representing. And the conclusion and the future enhancement, the this research article what I submitted and this presentation also, it is a clear comparison between the how between the normal general bird and how the domain specific models are dominating over the bird when it is execution, while the time of feature extraction also, while the time of taking the specific word and subword understanding and all. So the advanced studies, which means the pre-training of this model is quite difficult. Why? Because we need that kind of supporting memory and all. So this kind of models that top-notch companies are using. The advancement we can use, which means we can take and we can specifically we can pre-train for any specific purpose, any specific domain area purpose we can utilize. And these are the reference I have included. And thank you.
Now it is a time for the questionnaire. The session chairs can ask the questions.
Hello,
Yes, sir. Yes, sir.
Pranjit here. So I have
Okay,
one
sir.
question for you. Why
Okay.
do you restrict your research to this one bird model, like SciBird only? So you have reviewed clinical bird and biobird also, but in the experiment you have shown only SciBird.
Okay, sir. This specific, I have included many models. This is one of the part of the research. So I included the comparative study only for the bird and SEA bird only. Why? Because when I compared all the three models, actually I did the comparison between the SEA bird, clinical bird, and bio bird. In that, I got the better accuracy in that SEA bird only with the bird. Why? Because it is containing 82% of computer sciences are there, and rest of the things is biomedical. That is the difference is coming with the bird and SEA bird. And the rest of things are it's not comparable also with bird. So only I took these two.
Okay, thank you.
Hello,
Yes, sir. Yes, sir.
I'm Balasubramaniam.
Okay, sir.
Actually, this is a research paper or a review paper.
This is a comparative study only. This is a part of my research only. This is a comparative study between how the token identification coming with the bird and token and subtoken identification of bird and SEA bird, sir.
What is your contribution in this paper? What actually you did? Can you say any novelty of this work? Actually, by your own, you can did this like that.
Oh, okay, sir. I got the question. Some ways it is breaking also, but I got the question like that. But the drawback of this pre-trained models, which means their structure is fully like a bottleneck like that. For example, but if we are taking 12 layers of structure, what are all the parameters?
Actually, I asked that what is your novelty in your
I
work?
want to add one more layer, which means it is possible. But there is a tall layer of architecture, which means we cannot include one more layer in that. So it is closed architecture like that. If you want to do anything, which means we have to do outside of that or after implementing that. That only we can do. So in my research, this is a comparative analysis study. As a part of research, I did it. So what I did as a contribution is not coming in this article, but I have done like the sentence embedding merging. I did it, and after that only I included the context and question to the bird model. Not only the bird associated. So many models I tried. Albert, Roberta, digital bird, long form. There are so many models I tried. So that is one of the challenge when we are taking these kinds of pre-trained models, because inside it is fully closed. It's like a black box. So there is limitations to do some.
Okay, actually, you can take your references. You can show me once again your references.
Just a minute, sir. PPT, right?
Yes, yes. Please show me that references.
These are all the references I have included only for this preparing the PPT only. Rest and all the complete
Please,
references I have
full,
included there
full,
in the.
full screen, full screen, please. Full screen. It's not visible.
Is it visible or?
Yes, yes. This is your references actually. You are taking the paper from 2017, 19, like that, right? Any recent papers you have gone through that in 2024, 23? Because last 2, 3 years, a lot of research going on this area, right? So have
Yes, sir.
you
Yes, sir. Yes, sir. Yes, sir.
have you
But
explored?
yeah, SEA-BIRD is developed only in 2009 nine only. So that and BioBIRD, SEA-BIRD, and all these things, 2019-20 only it is developed.
Actually, after that, there is no further enhancement in cyber as per your point.
Yeah, yes, there are so many enhancement that. Why? Because when I
Then,
start,
then,
yes,
then
sir.
why do you not go through that purpose? That
Yes, sir. Why? Because the comparative study I did only with the bird and bird-based, domain-based model only. Now we are going, we can see so many pre-trained models like GPT, Llama, Meta family, so many models
okay,
are there.
okay, okay. Thank you,
But
thank
this comparative purpose, I have taken this.
you.
That
Okay,
is the
okay,
reason.
fine, fine. Thank you. Okay. Any question from audience? Audience, any questions? Anybody else?
Thank you, Miss Nisha Bagis. You can off your screen sharing.
Okay, thank you.
Okay. Next, we'll go to the second paper with the title Multi-Channel Stacked Text CNN, a robust framework for improving biomedical multi-label text classification. The author is Saikat Mondal.
Yes, ma'am.
Saikat,
Am I, au- am I
am
audible?
I audible?
Yes, yes, ma'am. You're audible.
Okay, you can start your presentation after the buzzer.
Okay. My presentation is visible, sir, ma'am.
Yes, it is visible.
Okay, thank you. Good afternoon, everyone. My name is Soikot Mandal, and I'm honored to present our research titled Multi-Channel Stack Text CNN, a robust framework for improving biomedical multi-level text classification at this prestigious conference. Before going into the details of our study, I would like to acknowledge the collaborative efforts of all the authors involved. This work would not be possible without the valuable contribution of Sikha Verma, Hemraj Kumabat, and Dr. Aditi Sharan. I'll begin by providing an introduction of research objective, followed by discussions of our proposed model, results, and conclusion and future work. Introduction. As we know that the biomedical literature holds immense importance in the scientific and healthcare communities, serving as a vital repository of knowledge and advancement within the biomedical domain. The real-time capabilities of online platforms have contributed to a significant increase in the volume of biomedical text, accompanied by a growing amount of disordered data. Actually, traditional manual classification method for biomedical text not only need significant human and material resources consumptions, but also pose extreme challenges in executing large-scale classification tasks. Our research deals with multi-level biomedical text classification. In multi-level text classification, each input text is associated with multiple levels simultaneously, and it's become more complex when biomedical text come into the picture. Because unlike general text, biomedical text introduces a layer of complexity due to its highly specialized content, technical like featuring intricate terminology as scientific names, gene symbols, and medical abbreviation. Yes, research issues. From the vast literature review, we identified some of the research issues and tried to address these issues. The first one is the domain-specific representation. As discussed earlier, the biomedical text consists of specialized technical terms such as gene symbols, scientific names, and it is very important to have the domain-specific contextualized representation. Our research tries to address this issue by combining embeddings trained on biomedical literature databases. We will discuss details on this further slides. The next one is the potential use of CNN. Earlier, CNN was used extensively on image classification, segmentation to extracting feature from images. Though last 3-4 years, CNN has been used in text rapidly for capturing the feature from text, and there is also potential of CNN with the different hyperparameters like window sizes, number of filters. In the context of hierarchical feature extraction, uh, limited research has been explored. The significance of hierarchical feature extraction allows for the identification of both local and global features, hence contributing to a more comprehensive representation of textual data. Lastly, it seems minor gap in the implementation of efficient deep learning models for classifying multi-level biomedical text data. And coming to our proposed model, we will discuss the architecture of our proposed model. Then we will go for each component. From from this figure, we can see that we have used three embeddings at PubMed Win 30, PubMed Win 2, and by WordFake. And at the top of each channel with different input embeddings, two layers of stacked CNN is used. The first layer of text CNN consists of 128 filters with window size 2, and the second layer of CNN consists of same number of filters 128 and window size 4. And then the channel then channel specific representation are consolidated into a single feature vector through a concatenation. Through a concatenation. This integrated feature vector encapsulate the information from all three channels we used here, and providing a holistic and informative representation of textual data. And then after concatenation, we've passed to a dense layer and then output layer. In our proposed model to prevent overfitting in the network, we use dropout layer with a dropout rate of 0.3 and incorporated in the second layers second convolution layer each of the channel, as well as the concatenation layer. Additionally, early stopping is implemented with the presence of 5 epochs, monitoring the validation loss and reinsisting the optional weights to promote improved model generalization. The dataset used for experimentation in the study is the hallmark of cancer dataset. It has 10 levels. A domain specific embeddings. In our proposed model, we have used three domain-specific embeddings. The first utilizes a word-to-vec-based representation trained on PubMed abstract with window size 2, and the second employs another word-to-vec-based representation trained on PubMed Central with window size 30. The third we used the bio word-to-vec representation based on fast text trained on combination of PubMed and the Mimic3 databases with window size 20. The reason behind that domain-specific word-to-vec training with varying window size can improve contextual understanding. With different window size can capture the context of actually different window size and capture the relationship between that. Another motivation for use fast text representation, because in the word-to-based representation we suffer from the out of vocabulary problem. Multi-channel stack CNN. Our research distinguishes itself by incorporating stacked CNN into our model. This novel approach gives several advantages. Stacked CNN captures the intricate relationship within the biomedical text, improving the model's understanding of complex pattern. The second one, the stacked CNN provide increased model depth, enabling the extraction of hierarchical features at the multiple levels, beneficial for discerning symmetrics within the biomedical text. And another is that compared to the more complex deep learning architectures, stacked CNN strike a balance between the model complexity and efficiency, resulting in improved computational efficiency with maintaining the competitive performance. This is GHSNet 1. In the state of art model, GHSNet model proposed by Muhammad Ali and Ibrahim and colleagues give the best result till date in classifying multi-level biomedical multi-level text data. So, for evaluating the performance of our model and observe the effectiveness of incorporating enriched embeddings, we have used this state of model GHSNet. At first, we reproduce the GHSN model with same parameter specified in the paper, and we have seen that GHS model use two word back representation, is PubMed Win2 and PubMed Win30. And here from this table, out of their out of vocabulary was present in two representation as given in the table. As we seen that from this table, PubMed Win 30 has the highest number of out of vocabulary words, and we replace this PubMed 130 embeddings with bio word back embeddings because it has the lowest out of vocabulary words, and we named this model GHSNet 1. By changing the embeddings, we find that improvement or in performance observed in terms of precision, recall, and F1 scores that highlighted it in table GHSNet 1. In results, here, our proposed model multi-channel stack tech CNN architecture has demonstrated superior performance as depicted in table, suppressing all other models with precision of 90.76%, recall 91.37%, and F1 scored 91.04%. You can find that increase of 4% compared to the GHSNet 1 model in terms of F1 score. Here, the lower box plot provides a summary of the performance of three models GHSNet, GHSNet 1, and our proposed model across three folds in terms of precision, recall, and F1 score. And here we can see that our proposed model consistently exhibit the highest median score across all performance measures. Moreover, our proposed model demonstrate stable performance across 10-fold value and showcasing consistency. The right side AUROC analysis visually represented in the right side image illustrated the impressive discriminancy capability of GHSNet 1, and MST-CNN in distinguish between the positive and negative instances. Notably, the performance of that our proposed suppress all the other models, demonstrating exceptional proficiency in minimizing false positive while maximizing true positives. In conclusion and future work, overall, I would like to conclude our model. Conclude our model encompasses CNN layers with efficiently captures both local and broader global features, due to which our model outperforms all the other state-of-art models. But still, domain-specific feature knowledge is not totally incorporated up to this content. And the future we try to incorporate UMLS-based medical term embeddings, and moreover, BILSTM attention can be utilized to extract more contextualized details for extracting details. And we try to validate our models with more biomedical data sets. Here are the references, and thank you.
Okay, now the time for the question answer session.
Hello, I am
Yes,
Prem.
sir.
Okay. So I
Yes,
have a
sir.
few questions to you. What are the motivations to choose word-to-vec and fast-text-based models for your research?
Yes, sir. Because word to fake first representation have one problem. There is out of vocabulary problem. That's why I use fast text based representation that is less amount of word out of vocabulary words problem.
Okay, basically there are other algorithms which can solve the OV problem,
It's
like
not
bird-based.
full totally, but some yes, some level in some level they can solve the out of vocabulary problems.
Okay, so why CNN? What are the advantages of using CNN in your network? Why didn't you try other networks? And one additional question related to that is, why did you call your model as stacked CNN?
Yes, sir. Yes, sir. In this our proposed model, we used consecutively two layers of CNN. That the first layer we use a small number of window size, and further we use broader number of window size. That actually at first at the initial level, they can capture the local relationship between the words, and the further we try to capture the broader or global feature. That's why we used this stacked CNN.
Basically, you have, I mean, you the multi-channel and the stacked are representing
Yeah,
the
yes,
same concept.
yes. At first, the first one, our motivation is to the hybridization of multiple embeddings, so that the medical we can capture the more contextualized vector. And then we use the top of that, we use the stack CNN for capturing global and local feature from that.
Okay, thank you.
Thank you, sir.
Hello.
Yes, sir.
Your proposed model name is multi-channel stacked text CNN, right? Right?
Yes, sir. Yes,
What do
sir.
you mean by multi-channel?
Yes, sir. At the initial level, we use three channels, and each channel we use
What are the channels?
different.
The channel means what you are meaning. Actually, three channels means what multi-channel? Three
Yes,
channels.
yes, sir. At the three different way we give the representation in
Three?
text. The way we can say that the three road from we can give the input, and top of that we use the stack CNN and incorporate all the feature vector that
I
given from
understood
three
about
channels.
that. Actually, I'm not getting about your multi-channel. What is multi-channel? That I'm not getting. Okay, that okay. It's stacked text CNN means how many CNN models you are incorporating in your proposed work?
Yeah, yes, we use the CNN.
How
There
many?
are
How
two
many?
CNN,
How many CNNs you are using?
two layers of CNN with different
Two,
window size, and
two layers
we
of
use,
CNN. Right.
yes,
Right.
stacked
So,
CNN. Yes,
what is the filter size in first layer one you have
the
used?
first layer we use window size is two, and for second layer we use four
Why
window
you
size.
choose that number 2 and 4? Why can't
Yes,
other?
so, sir. Yes, yes, sir. We experiment with different window size for different sizes, and we find it is suitable, and give the accurate result in this architecture.
Can you explain about that UML based medical term embedding?
Yes,
Can
sir.
you,
Yes, sir. So UMLS is a repository where the the knowledge about of medical term is present there. We are thinking to incorporate, like in text or in abstract. We use the abstract. There is so many medical terms present there. If we capture the knowledge that are externally present in UML's databases, and try to use our model that we are thinking to incorporate UMLS based representation, it will be our future work. Yes,
hello?
yes, sir. Yes.
Then what are the performance metrics, precision and recall? Why you have chosen precision and recall? Why other some other metrics are there, right? When we are evaluating the performance of the model, we cannot trust the values of precision and recall. There are
That's why we use
so
yes.
many metrics are there.
Yes, sir. We use the F1, focus on F1 score. That's really the
But by
balance.
seeing the values of precision and recall, we cannot say the model is performing well. So
So
have you
that's why,
explored whether you explore about other metrics?
yes, sir. But we use the focus on F1 score. That actually balance between
But
the precision and
currently in that
recall.
the models, when we are proposing the models, the performance evaluating the models not based on that precision and recall. We are go through different metrics. Just you have go through that also and try for that whether how your model is working on that. Okay.
Okay, sir. Okay, sir. Thank you,
Okay,
sir.
fine. Thank you.
Thank you, sir.
Thank you all. Saikat, you can now turn off your screen.
Okay, thank you, ma'am.
Now we are moving on to the last online participant, Miss Amandeep Kaur Gahir, with her paper title Cross-Domain Recommender System Using Deep Learning, a proposal. Ma'am, okay. You can start your presentation after the buzzer.
Uh, Good afternoon, everyone. I request to ask if my screen is visible.
Yes, your screen is visible.
Okay. Good evening. My name is Amandeep Kaur Gahir, and today I'll be presenting my part of my research called Enhancing Cross-Domain Recommendations Through Deep Learning. Basically, this is my PhD research work, and from that work, I am, quoting the proposal part only. So, starting with the basic definition of recommender systems, a simple recommendation system is a system which it is used to pick out and put forward the relevant items, services, offers to the consumers by considering their profiles, transaction history, preferences, opinions, interactions with the products and services as well as their relationships. The common recommendation systems we see across in our lives are very common. Amazon, Mantra, Flipkart, Netflix, everything uh, needs a recommender system. Now, what difference is there between the recommender system presented in our article and the others? Most of the recommender systems we see nowadays are in domain recommendation systems, but we are talking about in this work is cross domain recommendation system. Now, if we can see in the first part, what is involved is a single domain, two set of users, user set 1, user set 2. If I take the example of Amazon only, what basically they do is they study the interactions between users and domain 1. They keep on seeing that these kind of users have these kind of interest in the domain 1 items, and whenever they come across a new user from set 2, they just identify that this particular user is like some other user in set 1, and they recommend the same user to domain 1. Now, recommendation systems we come across, they use collaborative filtering and content based. All of them are in domain recommendation systems only. Coming to the second part, what cross domain recommendation system is, apart from having one domain, we are having two domains. After studying the interactions between domain 1 and domain user set 1, we come across new users and new domain. So we are to suggest items from second domain to second set of users. So the basic thing involved in cross domain recommendation system is transfer learning only. So, if I talk about any example that I have came across during the literature review, some recommendation systems they study your interests in movies and recommend you novels. Now, what happens is your interests are studied in the movies domain, but you are being recommended novels, and novels belong to domain 2, right? Some of the recommendation systems are also available which recommend us research papers depending upon our interest in books. So now our interest in books are being studied, but what we are being recommended, the research papers. So in the market, not very much cross domain recommendation systems are popular. Basically they are being used as a simple you know part to solve the basic problems of cold start, etc., in the one domain recommendation systems only. So after studying the recommendation systems, there are many kind of recommendation systems that can be categorized into collaborative filtering, content filtering, and hybrid approaches. So there is a classification of collaborative filtering which are memory based and model based, that in turn are user methods and item methods. Model based are the recommendation system which use deep learning models like the support vector machines and neural networks and all. Content based, if I talk about recommendation systems, are the systems which understand the content basically and then make the recommendations. They are item centered and user centered. The hybrid approaches, they make use of both of collaborative filtering and content based filtering approaches, and then make new uh, recommendation systems. They come under hybrid approaches, and most of the recommendation systems being popular these days, they belong to hybrid models only. if I come to the problem formulation, what happens is there is a lot of information overload on the internet. Even if we Google for a simple query, we come across with hundreds of results. In turn, we are to select from the 100 search results that which 10 results are useful for me. So we have a customer over choice. Amazon, Mantra, Flipkart, we need a single thing that we have lot of recommendations, but we don't need these much things. So we have an over choice. So that to solve that problem, we need a recommendation system which just understands us, which understand our needs, and only recommend us some things from which we can pick items that we need. Now, most of the recommendation systems work in single domain, as quoted in the earlier slide. What they basically do is they consider the user's profile, they consider user's personal information, they do the behavioral studies, and then suggests things to us. The common thing that we come across is that if I search one thing on Instagram, maybe. Even if I go to Goa Bibo and I search for Goa, next time on the Facebook and Instagram, I keep on getting the reels and tour travels from Goa only. So this is an example of personal information studying and behavioral studying only. So this would be an example of, again, single domain recommendation system only. uh, what we are presenting here is a cross domain recommendation system. For example, a recommendation system which understands um our needs in one domain, for example a novel, and then we are being suggested with a movie, right? So what happens is this strengthens the quality of recommendations. We are not again and again being suggested with the same things. We will be uh, provided with the variety of recommendations. So this thing is called cross domain recommendations, and the basic technique which works behind it is transfer learning. So the basic application which I am working on is educational entertainment. So if I put this thing the another way, that there are students who are interested in many things. One student may be interested in stock market, and what if he is being suggested with different stock market books, research articles, news as well. Now books, research articles, and news, they belong to different domains, so he will be getting good quality of recommendations. He will be getting enhancement in his knowledge as well. So this particular thing is educational entertainment, that while surfing, while doing his daily web searches, he is also being suggested with educational things. So this is the basic proposed design. So we will be considering one user, and from the source domain, his behavior his behavior will be analyzed, and from the source item data sets, the item features will be extracted. So for making a cross domain recommendation system will be made. For making a cross domain recommendation, input from one domain recommendation is needed. For implementing this thing, there will be no such kind of data set available that will be already giving me that these kind of people like these kind of items. So I will have to make a in domain recommendation system first. From the feedback of the in domain recommendation system, I'll be making a cross domain recommendation system, from which I'll be using data set 1, 2, 3, and from target data sets I will be suggesting making cross domain recommendations. So this is the kind of thing that I am expecting out of the proposal I have done. Example, I am given with the information that this is a student, he is having age 9, he is from middle school, and he is very much interested in dogs, and he already liked one of my book preferences from in domain system, that inside of a dog what he sees, smell, and know. So depending upon this particular knowledge, he should be getting these TV production or movies, news articles, and YouTube videos. He should be suggested that you should also be watching Dog's Way Home movie. You should also be watching A Man with His Dogs. You should read these news articles on dogs, like "Don't abandon us, we don't transfer COVID." You should also be using the YouTube videos like these. So there are other examples as well. So for the same thing, I did the literature review, which enhanced literature review has already been published in another journal already. So I'm just depicting that I have read these papers, studied these papers. The reason behind including these particular papers only are because of the recommender system they have made. I have studied these recommender systems, and they were actually helpful to design this particular system I'm working on. So coming to a bit detailed research methodology, I have just included in the PPT that um, from the user, I took his demographic information, everyday questions, and what kind of web search he is making. And I did the basic user behavior analysis to do the in domain recommendations. And then using the feedback of in domain recommendations, I have made the cross domain recommendation system, which gives the TV production, news, and movies recommendations. This is just a use case. Otherwise, like use case of educational entertainment. Otherwise, till now, I have kept the things generic, that source domains and user domains can be varied with the datasets. So for this particular study, I have used a books data set from Amazon only. It has 2935525 unique books, a big data set. And then I have done some user behavior analysis, and in-domain recommendation system has been made. The initial response it was recorded, and then from the target data items, TV productions, news, and educational YouTube videos I have considered, and these are used to make the target domain system. So till now, this paper, till now I have only designed the system. The system is working at my end, but it is being tested with the real time user. So that is why I have limited my paper till now to the proposal part only. So the conclusion is that the paper serves as a comprehensive proposal for a novel approach to cross domain recommendations. Although this is the basic results are yet to be obtained, we anticipate that our approach will significantly improve the recommendation accuracy across the domains by iteratively refining the suggestions based on the user responses. We aim to demonstrate the effectiveness of cross-domain recommendation making in enhancing the user experience and engagement, especially in the educational entertainment part. So overall, this research contributes to the advancement of recommendation systems by proposing a novel approach which leverages the deep learning techniques to bridge the gap between the different domains and provide the more personalized recommendations to the users. Thank you so much.
Now the session chairs may ask the questions.
Hello.
Hello, sir.
I have a few questions
Sure.
using the proposal.
Yes, sir.
So missing data problem is one of the most important problem in recommendation systems. How are you going to solve that or address that issue?
So missing data problem is basically whenever we log in into system, the data in my research methodology, if we see, I have included three things. One is users behavioral data, demographic questions. Demographic questions are like, even if we recall some of the apps we use, they ask they keep on asking everyday questions, that what is your mood today. If I'm talking about a calm application, they say what is your mood today, what are the things going into your mind. So by interacting with the user only, they figure out some of the keywords that I am interested in.
Okay,
Even
so
if I have nothing, even if I ask,
you don't
yes,
have any such issues in your data.
no, no. Apart from that, I'm also considering top 5 Google searches I have made. The user will be telling us the top 5 searches that he has made, so they will also be helpful for keyword extraction. So basic keyword extractions will be done from there only.
So the next question to you is, so you have shown some inputs data or input format to the model. So
Yes,
what
sir.
are the things that you are planning to convert the input data into some matrix format?
Yes, sir. I have basically I'm implementing using this Jupyter Notebook Python only. So all of these data sets, they are the data set I have shown now. They are in raw form. Firstly, they are completely refined. The noise has been removed, and the data set, obviously, they reduce to their size. And then after selecting particular attributes, only the attributes that are needed for the theme generation, only they are being carried forward. Rest of the data is not carried forward, because such big data is not possible to be processed using our Jupyter Notebook. um, um,
Okay, you
yes.
asked about the algorithms that you can use for converting the data into
Yes, sir. Yes,
better.
sir. Sir, first of all, a basic EDA has been done, right? So after that, I am basically using these things: cosine similarity, NNFM, non-negative matrix factorization, LDA, LSA, LDA to VEC, and deep belief networks. These 6 models I have used for generating the recommendations only. But before making the recommendation engine, various NLP techniques are used for text cleaning and keyword extraction. The main thing that I am using different is LDA. It is latent directly allocation. It is a thing that I am not using the keyword based approach, rather I am using the theme based approach. So this enhances
So you
um,
have
the
noise in your data. So the noise can present the text data in your base.
Yeah, sir. Whatever like big data sets we get from Amazon and even YouTube videos, they are very noisy. They need regressive exploratory data analysis and data cleaning. So that part is done manually
Okay, thank you.
using Python. Yes.
Hello.
Hello, sir.
Actually, your topic, paper topic is cross-domain recommender system using deep learning.
Yes, sir.
Is it a research paper, review paper, or proposal paper?
Sir, this is a proposal paper for now.
For the proposal, right? There is no implementation part or results and all.
Even the research methodology included in the presentation, it is limited to the presentation only. It is not included in the paper itself.
Okay. Actually, why you use the term using deep learning in your title?
So because whenever we generate the cross domain recommendation systems, na, we'll have to include the algorithms such as LDA to VEC, LSA, and deep belief networks.
Question is why you use the term using deep learning like
Yes,
that? Why?
yes, sir. Sir, these algorithms use deep learning networks only. Deep belief networks, again, they have a neural network.
Okay.
So
Which deep learning algorithm you are using in your method?
sir, first of all, LSA, latent semantic analysis, deep belief networks, and LDA to VEC.
Whether
All of
whether you have already done this method or applied this
uh,
method in.
yes, sir. Sir, at my end, I have done these methods, but for generating the results part, I am considering real life users, and I'm getting the
But in
recommendation
your
results.
paper, there is no, there is not mention about anything about the deep learning methods and the proceedings in your paper. There is not having any idea about the deep learning algorithms or methods which one you are using. But in
Okay.
the title, you are mentioning that you are using deep learning, right? So
Basically, yes, sir.
actually, you are
Okay.
generally give that information. We are
Okay.
going to use that machine learning, deep learning, or natural language processing like that. Only you mentioned in your paper.
Okay, I understand your things.
Now you have the idea of which method you decided to going to use or already used in your work.
Sir, for my work, I have tried generating recommendations using these six methods already. Six algorithms I have already used.
Okay, mainly you are saying about the behavior analysis and feature extraction in your work in the presentation. During the presentation, most
Yes.
of the times you have mentioned that behavior analysis and feature extraction. How you
Uh,
are doing that behavior analysis from the user?
so
Any
behavior analysis using everyday demographic questions and the Google search results and the basic profile. Whenever they'll be using the recommendation system, user makes the profile, and whenever the profile is made, the basic demographic system questions are asked. What is his age? Is he a school student? And in what grade he is?
then why you not included those details in your paper?
Sir, I think they are there in the paper in the basic proposal diagram only.
Only that explanation. There is no explanation in the paper how it will be doing. Just to block diagram only you have given. Feature extraction. Which feature extraction you are using?
Um, Sir, after the basic case diagram, uh, I have mentioned the things in in
Okay.
concise
Okay.
manner. Maybe
Okay.
yes.
Okay. Thank you.
Thank you so much, sir.
Thank you, Amandeep. You can stop sharing the screen. Our online presentations are over. Next, I would like to invite Akshay S. for presenting the paper, Comparison of Explainability of Machine Learning-Based Malayalam Text Classification.
Hello all. Um, Hello all. My name is Akshay. I'm basically junior year, so basically third year student from IIIT Kottayam. And so I'm here today to present my research findings on um, so basically, my topic is classification of explainability of machine learning based Malayalam text classification. So, um, my paper was co-authored by uh, Dr. Manoharan sir, and then yeah, that's it. So, okay, so before um, okay, so let's start by setting the stage. So, what? In this world of world where machine learning and deep learning algorithms and methodologies are moving very fast. It's very important um, to know the criterion basically how the model is predicting and what are the criterion behind the prediction and why a particular uh, we got. So yeah, uh, so that's very important. So, uh, so that's what I'm going to that's what our model paper is on. So basically, um, we are performing. We basically have an algorithm based on which we are um, with the help of which we are basically comparing the explainability of different machine learning and deep learning, different machine learning models and some well-used deep learning architectures. So, um, before we dive into the methodology or our findings, let me give you all a background on what our to what background and objectives of what we have done. So basically, as you all know, as everyone might be knowing, mostly knowing, like Malayalam is one of like very well, very much spoken languages in Kerala. It's like almost 34 million, like, which corresponds to almost 3 crore 40 lakh people around the southern region of India, and like Pondicherry, and it's spoken around there. So. Uh, so basically, transparency and interpretability of any model is as important as its performability, like its performance, and how well it works with respect to performance matrices. So basically, that will help. When one is trying to deploy a model or use some model for commercial purposes, or like if one wants to remove the bias with respect to uh, like model, and if one wants to scale model, like interpretability is like a very important criterion there. Okay, and then so what we are doing here is, so our objective is basically is to perform a systematic evaluation and comparison of the explainability of different popular ML models and some DL architectures, particularly for Malayalam text classification. Um, yeah, and then and like we are discussing the factors influencing the model discussions and the trade-off which comes in between performability and interpretability of the given model. And so yeah, um, okay. Let's go through the methodology which we followed. So basically, yeah. So basically, we started with collecting data sets. Like it was not that easy of a task, or like to get much of. There were not much publicly available data sets which when it came to Malayalam. Uh, Mostly, there were some uh, Indian classification uh, Indian classification based data sets, and then we could find some news classification data set too. Also, yeah, then we'll discuss. And then what we did is we did pre-processing. We performed first we removed first we removed the stop words. We first tokenized and removed stop words. Then performed lemmatization on the uh, particular words, and then yeah, that's what we basically did in pre-processing. And so basically, so when it comes to Malayalam, um, even those tasks were not straight through, because there were not like implementations of these things in maybe like well-known libraries called scikit-learn or um, okay. Stop words. Basically, we had to curate on our own. So basically, what we sorry. What we did was we took um, stop words which was uh, mentioned for English in NLTK, and then we performed we translated them, and then but then what we had to do is we had to manually check which works and which doesn't work, and we had to add more stop words, which we got from like which we had to curate on our own. And then when it comes to even when it comes to stemming or lemmatization, we had to work around by there was basically a library named MorphGen, like which we have cited, and then which basically splits the if so in Malayalam, basically in a given bigger text, it splits the text into its base words. So so like that's what we use here for lemmatization. So it's basically not stemming; it was a lemmatization, and then we performed EDA. In EDA, what we did is we basically like went through the data set distribution, class distribution and stuff for the different data sets we used, and then and also the lengthwise, like the distribution of lengthwise and character, word-wise and character-wise length and all, which we used, which was actually yeah. And then we embedded the text. We converted it to vectors. We used different text embedding techniques, like, and we used which was working the best. And then basically, and then we had different ML models which we use, and different deep learning architectures, and we uh, okay, so basically we used those models and architectures, and then we tuned those models to make it work the best, and then yeah, and then okay, basically in EDA we also so for each class, for each data set, for each class, we took the most prominent words. So basically, so most occurring words, most frequently occurring words, along with after, most occurring words after removing the commonly coming words or stop words. After that, so on doing that, we received the um, um, uh, words which were for that particular class, which words were important. So that we achieved after performing EDA for each data set, each class. And then yeah, so we then after tuning, we just got the results and checked our okay, and then basically what we did after that was we performed explainability. So we used Lime and Lime. We used in Lime. What we did was we were able to. So basically, what Lime does is it takes a separate instance and creates a like in the linear model around that instance, so it will not have to take the whole complex model. So basically, using Lime, we also got the most like what models are what words affect the text. So using that, what we did is there was a bird cased model, using which multilingual bird case model, using which we were able to embed the results we got by got via EDA and LD line. And then what we did was we did cosine similarity to get the score. Yeah, also when it comes to data sets, we used three different data sets, and basically their distributions were fairly equal, their class distributions. And so we did this because so that we could remove the bias factor, or the so that we could basically generalize. Yeah. So basically, here we are explaining the same things. Also, these are the deep learning model architectures we used here. So like there was CNN and LSTM model. There was a basic feed forward network, and then just LSTM, then bidirectional LSTM, and then CNN with bidirectional LSTM. Um, Yeah, and then these were basically the EDA results. Word number of words. So yeah, so for each data sets, number of words and word count for each of the words data sets, and then based on yeah, then this was the EDA result which we obtained for this is basically for the Malayalam news headline dataset. Also, we performed LDA. We basically did a seeded LDA technique using which we use the instances which most popular um, um, so most occurring words. We seeded our LDA with that so that we could get the topics in that format. So basically, when we just analyze into it, we can see the first topic ID 0 is basically corresponding to the business field, and then topic 1 is basically corresponding to the sports field, and so on. Yeah, so on yeah, this was a performance metrics results we achieved. Basically, um, extra trees and SVM performed well with respect to this, and basically the for um, basically, yeah, here we also so basically calibration curve gives us the it basically tells us how interpretable or how corresponding to the real world our results we got with respect to the probabilistic measure of the corresponding machine learning or deep learning model used is. So basically, using that, what we found is so basically using calibration curve, we want our curve to go as close as possible to the x equal to y line. So when we were working with the machine learning models, we found there were many models like um, linear regression, and then I think extra trees were extra tree classifier was basically very close to the x equal to y line. Also, but when it comes to deep learning models, it varied for different classes. Some were doing good with respect to some class, with respect to the real world. Yeah, and then this was the explainability result which we achieved. So basically, what we could find is there was basically a trade-off between explainability and explainability and the performance of the this thing, the model. When it came to performance, extra trees were actually not working as well compared to other deep learning methodologies. But when it came to explainabilities, basically these were the scores which we got by getting doing cosine similarity on the BERT embedding using multi-case cased multilingual BERT model which we use. Um,
Actually, your topic is what? A comparison of explainability of machine learning based Malayalam test classification.
yes.
But you made your paper very complicated. Why? Actually, your paper looks very complicated. But your title is comparison of explainability of machine learning based Malayalam text classification. But you have informed, so you have given so many things. You presented so many things. ML model, DL model, then you go for explainatively model. How this one conference paper you do the lot of things and make it as a paper, and there is no clarity. Actually, I did not understand why you have used ML, why you have used DL, why you have used the explainability model. Actually, your title is comparison of explainability of machine learning based Malayalam text classification, right? Then why much this complexity?
So basically, the most important part comes. So basically, most important part comes from the explainability part. So like where we are comparing the explainability of the model by taking after taking the we are curating both models. So here the first part is also calculation. get the result, like EDA is like actually very important. So, from where EDA is
Understood.
even
But after that, you are used to machine learning, deep learning, and comparing so many things. So actually, you are a third year student, right? So you have gone through all these models. You have know that how these models are working. All these deep learning models and yes. Can you explain about that? You are one of your machine learning model you have used is XGBoost and light GBM tree algorithm. Can you say what is the difference between XGBoost and light GBM tree algorithm?
so the difference. Um, so in boosting model, I'm not sure about.
Okay, then can you say your explainability model? You used to that explainability text classification model, lime and shape. What is the expansion of lime and what is the expansion of shape?
Yeah. So line data.
Yes, yes.
Yes.
So, but my suggestion is you are a third year student, when you are doing a presentation, make it as clarity. It's very clear what you are going to do.
Yes,
But
local interpret key of.
okay, okay, no issue. You
Sir,
definitely will forget.
I
So
can
that is not an
explain.
issue. But I am telling that you can come with a simple thing and present it nicely, then it will be good. So you are taking so much of things. It will be difficult to present also. Okay. Okay, okay, fine.
Sir, I can explain.
Okay, no,
Line.
no issue, no issue.
Okay, Akshay, I appreciate your efforts being an S3, sorry, third year student. You have put a lot of effort in writing a paper and conducting this much experiments. So I have one question. How did you compute these explainability scores and how these scores are actually explaining the models details?
Yes, sir. So after EDA, we got the best most common words with respect to different classes for each data set. We got the like uh, most occurring words, and then so basically what we also we took these words and put it in LDA, so we got the most important topics too. So basically what we found out was that these words, right, also we removed the commonly occurring words from the, so like taking all the three things after performing EDA, we removed the commonly occurring words in each three. So those three words were the basically corresponded to that specific class. So also, and then using lime, what we could get is we could get the for each class why it is being predicted like that. So we got the specific. So using line, we can get the features, most important feature for that specific class.
I
So
understood. So when you present, you can focus on your selling point, like the LDA and this explainability, rather than focusing on the other part of the presentation. So that caused the problem. Okay,
yeah,
thank you.
I didn't realize the time which is spent.
Okay, so you are a beginner, no problem.
Thank you, Akshay. Next, I invite Arfana Vivi to present the paper Aspect-Based Sentiment Analysis for Enhancing Customer Satisfaction.
Good afternoon. I'm Arfana Vivi. I am doing my master's in data science at the Department of Future Studies, University of Kerala. My paper is on expert-based sentiment analysis for enhancing customer satisfaction. So we will be dealing about introduction part, the literature review, objective, the methodology we used, data collection, exploratory data analysis, aspect extraction, aspect inference, and sentiment detection. Finally, results and conclusion. So, we know that the emergence of online platforms enable customers to share their experiences in a robust way, which is impacting customer. Impacting brand perceptions. So we know that it became a pivotal aspect that helps us maintain a competitive edge between the industries. So aspect-based sentiment analysis has emerged as a valuable technique enabling business to extract deeper insights from customer feedback by analyzing specific aspects. So in the case of general traditional sentiment analysis, we take the reviews as a whole and the sentiment associated with the reviews is considered in general. So if a review consists of both positive and negative sentiment that is associated with different aspects, we will not be able to find the generalized sentiment of the review. So in this case, we split the review into different aspects and the sentiment associated with each aspect is found out individually. So it is a specialized natural language processing technique that goes beyond traditional sentiment analysis. So while traditional sentiment analysis identify overall sentiment that is positive, negative or neutral in the text, ABSA takes a step further by focusing on specific aspects or entities within the text and determine sentiments towards each aspect. So moving on to literature review, I have considered 3 papers. The first one is summarizing online movie reviews, a machine learning approach to big data analytics. It has a lot of advantages, which includes automation, accuracy, speed, customization, etc. But also, due to the summarization, it has disadvantages, including interpretability, bias, overgeneralization, and maintenance and updates. The next paper is a personalized recommendation system using machine learning-based sentiment analysis over social data. The advantages include personalization, improved user experience, accuracy, scalability, real-time adaptation, etc. But due to it is based on the social data, so it has some disadvantages regarding privacy concerns, data quality, algorithm bias, and over dependency on social media platforms. And the last paper is hybrid sentiment classification on Twitter, aspect-based sentiment analysis. It also has an improved accuracy level, aspect level analysis, flexibility, robustness, and reduced bias. Since it's a hybrid sentiment method, the complexity level is much higher, so it requires a lot of resources, and the integration challenges occurs in the case of hybrid methods, and there's a risk of overfitting and interpretability. So moving on to our objective. Our objective is to extract and analyze specific aspects mentioned in the reviews, including product quality, customer service, prices, and more to gain a valuable insight into customer sentiments towards different aspects of shops and dealers. So the methodology we use is, first we collect the reviews that are made by the customers. The first process is data collection. Data is being scrapped from social media platforms. Next, we know that the data we are collecting may not be completely clean, so we need to process the data. So we move on to EDA and feature selection. We remove duplicate records and filter out values that are only relevant for our study. Next, we move on to aspect extraction. In this process, we extract the aspects that are relevant for our study. We know that when we consider a review, there may be a large number of aspects considered. So we need to find the most relevant aspect that is being discussed in the review. So that is being considered in the aspect inference stage. Next is the sentiment detection. That is, using a pre-trained model, we will be detecting the sentiment that is associated with each aspect. And finally, we will moving on to the result part. Our result will be an interactive report that is created in Tableau. So in this method, we will be using 3 algorithms. The first one is BERT, that is bidimensional encoder representation from transformer. It's a transformer-based machine learning technique that is used for natural language processing. It is pre-trained for sentiment analysis, so that it gives us a report as a number of stars, that's from 1 to 5. So it helps us a lot in sentiment analysis, and it is also available to work in almost 6 languages. And the next one is old mini LM L6V2 model from the sentence transformer. It helps us to find the relationship between the sentences that are present in the reviews. The last one is Space's English model, that is Encore WebSM, that helps to for English text pre-processing. It gives a structure for the English data. Next is data collection. In this work, the review data is scrapped from the web of our tile shops across the state of Kerala, India during the year 2023. It involves extracting consistent and actual text data from Google Maps, specifically focusing on the tile shop. Here we use Selenium for scrapping the data. This figure shows the metadata of the data set. The above is the store details data. It includes attributes such as name, rating, the overall rating that is considered, and the review count, category, the address of the shop, the time when the review is being published, the phone number, PIN code, and the city where the store is present. And the customer reviews data consists of the store details, the city, the overall rating given for the shop, the rating, the individual rating that the customer has given, the review of the customer, and the duration at which the review is being published. This gives the sectional view of the store details data and the customer reviews data. As you can see that in the store details data, there are shops that have zero number of reviews, or the reviews are less than 10. So taking into consideration those stores will not be efficient for our study. So we need to get rid of such stores. So this is being done in the next step. In the exploratory data analysis step, we have 7 main steps. First one is data cleaning. Of course, we need to get rid of the duplicate values, and also keep only the most relevant ones. In the next step, we do PIN code extraction. This is done so that we can find the exact location of the shop, so that we can find the geographical relationship between the stores that are present here. Next one is review count filter. We count the number of reviews that are present for each store. If the review is less than 10, we tend to delete the store, because the lesser the number of reviews, we will not be able to find the exact review that the customer has tried to share. The next one is review word count analysis. We tend to find the number of words present in the review, so that we can find the potential outliers. Next one is word length threshold. If the review is so long, that might not be very suitable for working. So we find the word length threshold. If the word length threshold is more than 99%, we get rid of the data. And next one is extract brand name. We extract the brand name so that we can find the customer's preferences for specific brand. The last one is word count creation. In word count creation, the word count of the reviews is done to identify the main topics or the most frequent words mentioned by the customers. As you can see, the most common words used here are good service, tire, staff, wheel alignment, etc. Next, we move on to aspect extraction. This procedure makes use of text reprocessing techniques with the text hero library that includes changing text to lowercase, removing punctuations and numerals, etc. Next, we find the prominent terms that are linked in the analysis. A frequency-based strategy for aspect extraction is utilized here. The method starts with the identification of nouns using a parts of speech tagger. The parts of speech tagger identifies each term to a grammatical category, so that we can tag them in a very useful way. The next, later we found a thematic relationship-based approach follows, where we identify noun terms using the Tracy's English model, which is used for English text analysis. And last, a comprehensive text main dictionary is created that encompasses the full scope of our aspect by merging both dictionaries. As you can see, the list of domain relevant aspect labels are given here. So we can see that there are a large number of aspect labels. So we need to find the most relevant aspect labels. So this is done using aspect inference. The NLTK and rigorous function are used to break up the reviews into separate sentences. The rigorous function is used to find the patterns that are being present in the data. The next step is to utilize the old mini-LM L6B2 model to encode each sentence and aspect independently. In this step, the textual data is converted into a numerical form. And the cosine similarity between the encoded sentence and the each aspect term is done to determine the most appropriate aspect of each sentence. To ensure the accuracy of our aspect identification process, a threshold value of 0.25 is established. So if the threshold value is above 0.25, we accept the aspect, or else we classify them into a miscellaneous category. This gives us a more sophisticated idea of what our consumers are discussing and how their opinions connect to the various features of our each shop. So we are given a list of aspect labels and the related aspect C terms. So the first, we can see that the term is quality and the terms related to its satisfaction, decent, brand quality, etc. Now we find the number of times the terms has occurred. We find that the word service has occurred the most number of times. Next, we move on to sentiment integration, in which we find the sentiment of each aspect that it's been found. The final task is to classify each sentence into 5 sentiment classes. We make use of the BERT model, which gives a numerical rating between 1 and 5 corresponding to each sentiment. This step provides a valuable insight whether the customer is providing a positive or negative or a neutral sentiment. So this shows a detailed review of a shop called Tire KMCM Traders, which is in Alapura district. So we can see that the first sentence is a quick and affordable service. So the aspect related to its pricing, the aspect C term is affordable. So since it's a positive review, the sentiment score given is 5. So moving on to result, we can create a dynamic system where users can filter data according to cities, searching for specific stores by name, filter results based on preferred data tier rank. This work opens the door to exciting avenues of future research and development such as label data acquisition, fine-tuning and embeddings, real-time monitoring, integration with customer support and multilingual support. So this is a snapshot of the customer sentiment analysis that has been created using Tableau. We have the aspect-wise sentiment score being displayed, so it can classify the stores based on our preferences. So conclusion, conventional sentiment analysis methods tend to overlook the nuanced topics discussed in customer reviews, constrain the capacity to make informed decisions. So in contrast, this work adopts a approach that translates conventional sentiment analysis by extracting the and scrutinizing the specific aspects addressing customer feedback. It underscores the efficacy of an unsupervised based approach in the system-based sentiment analysis, providing a foundation characterized by simplicity, user-friendliness, and reasonably promising results. So these are the references that I used for my project. Thank you.
The session chairs can ask the questions.
So in your model, are you feeding the aspect as an input to the sentiment classification model?
No, we are finding the aspect using species model.
So that why you are finding the aspect? Why are you finding the aspect?
Considering a review, it may be a long sentence, such that a person might have shared all his experiences, but we only need the aspect that required focus, such that if a customer service is good or not, whether the brand quality is good or not. So we only require specific points. So we find the aspects.
Now I kind of think of adding this aspect as an additional input to the sentiment classification model.
So we are scrapping the data from Google online platforms. So
that is my suggestion basically. Like, it may increase the performance of the sentiment classification. So are you facing any data imbalance in the data set or class imbalance in the data set?
not much.
How you collected this data?
We scrapped data from the online platforms, including Google Maps, using Selenium.
How many data totally how many data you are having in your data set?
Almost, I'm not properly, we took a large amount of data and we only created a subset that requires focus.
How many features in your data?
Almost 7 or 8.
What are the features? Can you remember the name? Can you say the name of your features in your data set?
Customer satisfaction, then product quality, then timing, and more like that.
Okay.
Thanks, sir. Thank you.
Thank you, Arfana. Next, I invite Jisha P. Jain to present the paper, Extraction of Textual Data from Unstructured Malayalam Web Resources.
Good afternoon to all. Myself Anju Vinod, worked as a programmer in CD. Our presentation topic is extraction of textual data from unstructured Malayalam web resources. We know that the amount of information available in the web is increasing day by day, and the user demand the most useful and reliable information from the web in the shortest time as possible. But it is not achieved immediately. In such cases, and because they may come, this may because That is some language barriers, or sometimes the user does not provide the exact specification of the requested data they demand. In such cases, user want to search in the information, or sometimes user want to extract the whole information from the web using different NLP technologies. About the 95% of all the data is available in web is in the unstructured format, and we extract the data from that. Come to the introduction section. Introduction section is mainly deal with what is text mining and what is the goal of our project. We know that text mining is extraction of information from unstructured text with a structured format using different NLP technologies. When choosing an appropriate method for information retrieval, it increases the efficiency and the accuracy of the data. The main goal of our project is to, when inputting a set of unstructured data, get a result as a pre-processed output. The next section is deals with what are the needs of text mining. Text mining is mainly used for the data extraction. So this is the most useful method for information retrieval, and it handles that huge volume of textual data using maybe in the semi-structured or in the unstructured format. The figure shows in here describe the basic steps of text mining. First one, we know that first one is helping the raw data, then undergo some pre-processing technique like tokenization, stemming, lemmatization, extra like that. Then it's undergo some future extraction techniques. Then finally analyze the data. If the user want to analyze the data for the sentiment analysis, then the text is classified based on the sentiments. If the user want to analyze the data for the test classification, then the analyzer test is classified based on that test. Finally, it undergoes some evaluation and visualization techniques. In this section, we discuss about the methodology of our project. The brief description of our workflow is, first one we define the query, then undergo content scrapping method, then collecting and storing the data, then undergo some text pre-processing method, finally stack the data based on parsers we stack. We developed our code in the VS Code platform using Django framework. The main packages are like NLTK, Google Trans, TQDM, and Scikit-learn. NLTK is mainly used for supporting the natural language processing packages. Google Trans is mainly used for the source code language discussion, because when the user enters the query maybe English or Malayalam, that time our system automatically detect the language of our query. Then next one is TQDM. TQDM is mainly used for the detection of source. TQDM is mainly used for getting the total iteration of the loop, and it also estimates the time taken to complete the whole loop and evaluate the speed of loop in iteration per second. Then we use the conditional random method for tagging. Then we use Python and Perl as a backend language. We stored our data in MySQL. This is the architecture of our project. First, we inputting a query. The inputting query may be English or Malayalam, and it contains single tokens and multiple tokens also. From the next step is information retrieval section. We collecting Malayalam text data from different Malayalam newspapers. For this purpose, we analyze almost 40 numbers of Malayalam newspapers. Only 5 of them satisfy all the criteria of others. That's our Manorama, Madhubhumi, Deshabhimani, and Madhyamam, and finally Pravasi Express. In the section information retrieval, first we scrapping all the links of based on our query using beautiful soup package and accessing total page count using pagination method, and finally access all the URLs and store the raw data for future purpose. Then it undergo some pre-processing techniques. The pre-processing techniques are Sandhi splitter, stop word removal, and finally spell checker. Sandhi splitter is mainly used for the compound word splitting, and spell checker for the spell correction, and stop word removal is used for removing stop word from the data. In this step, we get a pre-processed data as output that will store the data for our previous future work. This is the core section of our project. If the user wants to tag our data, then it's undergo the PO tagging section using CRF algorithm. Then get the result as part of this tagged data. This is one of the byproduct of our work. The another byproduct of our work is extracting Malayalam PDF file to text converter. These are the result of our work. First one is VOS tagging for Malayalam. Second one is text mining for Malayalam. The third one is Malayalam PDF to text converter. This is the main interface of text mining. The first section is for entering the query. It may be Malayalam or English. Then the user wants to select the newspaper for multiple or single one. The date section means the user wants to select the data from particular period. If the user wants the data selection from January 10 to February 12, we can select the from date to due date. When press the get result button, we get the result in two formats. First one is CSV file output and second format is text file. This is the output file of CSV. In this figure, we know that we get the 5 components. First one is site name, second one is URL, third one is title, fourth one is post time, and finally content. If the user want to download the data as a text file, it may contain only 2 components, that is title and content. This is one of the visualization result of our product. First one is word cloud. Word cloud is mainly used for getting the quick review of the whole data. And if the most frequent word occurring in the word cloud is in large size and less frequent word is occurring in a small size. Here we are using the result for mission query. Here from this figure, we know that Chennai is the most large word occurring in this figure. So the most frequent like occurring in the data is Chennai. The next most frequent word is Maya, Vishom, Bellam, etc. This is the another visualization result, that is frequency distribution. From also this figure, we know that the blue curve shows the most frequently occurring data, that is also the Chennai. Finally, the performance analysis. In this section deals the output of confusion matrix and classification result. Confusion matrix is mainly used for the visualization of the performance and also evaluate the accuracy of our model. From here, we get the total number of 93 data. Out of 93 data, 90 data are positive, corrected data, and 3 has some error because 3 has some error. From the classification report, we know that we get almost 95% of accuracy. These are some of the applications of our project. Mainly text mining is used for name identity recognition, settlement analysis, clustering the document, etc. like that. The next section is deals with the beneficiaries of our project. Usually, beneficiary deals with who all are beneficiaries with our project. First one is research scholars, second content developers, third one policy makers, finally the Malayalam community. For example, research scholars have want the data who you want the huge data for their process for the work. So our system is helping theirs to scrap large volume of data. Final section, limitation and future scope. One of the main limitations of our project is does not act as a universal model because our system follows standard written Malayalam type. If sometimes the user entering a colloquial word, it will affect the output of the query. The second one is accuracy problem. That mainly deals with if a tagged output, when a trained out content quantity and quality of the data increases, it will reflect the output. That means the accuracy of the output data also increases. If the data contains some ambiguous word, that means same word has different tags. So that less number of data is available in the tagged data, it will affect the output. That means accuracy of the data output may be decreases. These are the main limitations of our project. The future scope was we are incorporating our website with the various government website for getting all the government portal in all the government information in a single portal. Under one of the main future scope is so extracting the information from a PDF file. To conclude that our project is mainly focused on retrieving information from the unstructured Malayalam web resources. These are some of the references we used for work. Thank you.
The session chairs can ask the questions.
Can you go to the 12th slide? What classification?
Mainly based on precision recall.
No. For what task you are performing this classification? For what task you are performing this classification?
mission has a single word token given to our system, and we have checked manually. We have corrected checked whether our system is performing well or not. So when we gave the data for a limited period of time, we got about 93 results which connecting to the mission retrieved. But actually there was only 90 was the correct one, and some other was relating to some other term. So based on that, we have given this one.
So you used CRF for POS tagging. Okay, what are the features you considered for implementing CRF?
Main feature was used for dependency calculation of dependency in what?
Dependency information.
Yeah.
Okay. Can you give some examples?
For we have the almost 300 numbers of words. When we comparing dependency between the first word and 200 numbers, we can easily get the dependency between each word. We had a project before 3 times in which we have done the POS tracking, morphology, and dependency parser. So based on we have taken this as our training data, and based on this, we have we have added some more data to ours, and based on that, we have done this.
Actually, your proposed block diagram, extract text for query from Malayalam newspaper block diagram should be look like general actually. So can you say which machine learning methods you are using in that your work? Which machine learning algorithms you are using?
You mean for traffic?
It's extracting the text for query from Malayalam newspapers, that black diagram.
We have used the beautiful soup for the tracking one, and we have
You can take the block diagram actually that you have shown that one block diagram. Yes. Here you are saying using ML, right? Which ML algorithms you are using?
Yes, that is the mainly POS tracking, so that we have used
TRF. Why? Actually, I don't know about that TRF. Can you say what is TRF?
TRF is mainly used for the pattern recognition and
Full expansion of TRF.
conditional random tree.
Conditional?
Random tree.
Well, can you explain that? Actually, what is it?
So it is a discriminative model for pattern recognition. Here, for pattern recognition, we are using this discriminative model.
Why there will be some other? There are a lot of models are there, right, madam?
Yes, sir, we have already done with the TNT and SVM. So when we ourselves have compared our result with these three, so in that case we got CRF as a better one. So that we have implemented here.
Okay, which pre-processing techniques you are using, madam?
For pre-processing technique optimization, and we have developed our own service different search checker. So that is been implemented in that one, so that we get good results. So actually, after text mining, we have storing the data which we got as a one file. Later, after pre-processing this, splitting the compound words and removal of stop words, we have keeping another file, which can be much more useful for research purposes.
How actually you explain about the data set, right? So how you collected the data set? Actually, this data set.
So actually, we have scrapped the data.
How many data sets, madam?
Based on our query, we can scrap as much data we want.
How many data? How many data you have used?
For one, sir.
So you have shown that the confusion.
POS tracking means we have around 2 lakh tokens.
Okay, you take the confusion matrix. You take the confusion matrix. So show that.
So this confusion matrix is actually for text mining, not for POS tracking.
Okay, here how many samples you have taken for generating this confusion matrix? So actually total samples here.
Because actually we have scrapped the data between two dates which we have given, and based on that we got about 93 data which related to the given query we shown. So actually for this purpose we have manually checked how much we got that accurate the result was.
Actually this number is not visible. Actually what are the numbers in the 4 squares? 90? Okay.
Thank you, Jisha.
Actually, okay, you are correct, sir. But this is only research purpose we have using, and we are not going to implement it anywhere. Actually, our main aim was to.
If you're okay, then you can check their website. In their website, they clearly mention that scrapping or using of any information from their website is the entities are legally liable, and they are not provide any copyright, okay, to the end user to scrap the data. They are clearly mentioned. They also pointed that this data cannot be used for building any ML model or LLM model. That you can see on the Mathrumi news site, that on the terms and conditions they are clearly mentioned.
Sir, okay, that I understand, sir, but we have not used this for even if for POS tagging or anything. We have not used just for the.
That's what I'm saying. You no need to use it. The scrapping is illegal.
Yes, sir, that I
Okay.
have also seen, sir, just for checking whether this works or not. We have used this
Okay.
one.
Any further work, please make sure that the data that you are fetching is
Sure,
publicly available. Okay.
yeah. Okay.
Thank you, Jisha. Next, I invite Liji SK to present the paper BioQA BERT, a hybrid large language model for interactive Malayalam question answering system on health domain.
Good evening all. I am Liji. I am a research scholar from SS College Areekode under Calicut University under the guardianship of Dr. Muhammad Ilyasmi. This is one of my part of my research work. My paper titled BioQA BERT, a hybrid large language model for interactive Malayalam question answering system on health domain. Human-computer interaction is an every mission of mankind. Since the advent of artificial intelligence and modern computers, it is achieved through NLP, machine learning, and deep learning techniques. Nowadays, you all know LLM and ChatGPT-like models are become very blooming impact on this area. Question answering system and information retrieval system act as an interface between human-computer interaction. There is a huge volume of data scattered in the web. The more accurate and correct information retrieval from this vast amount of data is a challenging and tedious task. Here we developed a Malayalam question answering system on health domain. The system capable of addressing users' queries concerned to their health and wellness. System will analyze the query, match it with the corresponding documents, and generate the result. The main motivation behind this work is during my literature, we identified that there's a few number of very low number of researches are happening in question answering, especially semantic level question answering in health domain in native languages like Malayalam, other local languages. Also, India is a multilingual country. The question answering system on an active languages is a very important and necessary task. Main challenges faced during our research of parameters, number of hidden units, and number of layers. All of each of them have two variations, but large and but base. These are also vary from number of parameters and number of layers. Train these BERT models with the different our health data set and fine tune it with MQAD or annotated MQAD Malayalam question answering data set. As in a reader retriever format, reader retriever architecture generally used for open domain question answering. First of all, the retriever selects top 10 relevant documents. Here we select top 10 documents. After that, retrieve top 3 most relevant answers using reader architecture. This is the sample result obtained during our experiment. The result obtained as a paragraph or sentence. This is the result analysis. F1 score, precision, recall, F1 score, number of documents, speed. Here, from the experiment, we identified that Roberta achieved highest F1 score and lowest processing speed, and Distilbert achieves lowest F1 score and highest processing speed. We take the model Roberta, then proposed a new BERT model, BioQBERT, enhanced BERT model with Roberta and Llama. In order to improve the accuracy and the relevance of the retrieved answer, the output of the BERT model is fed through the fine-tuned Llama. Llama is a large language model, Meta AI. It is already trained with billions of parameters. Also prompted with the result of BERT model with a prompt. In order to improve the accuracy of the question answering model, we can get more precise and relevant answers. This is the overall architecture of the BioQA-BERT model. About the performance analysis and evaluation, the F1 score increase before introducing Llama 0.8645. After introducing it increases 4%, 0.9028. These are the evaluation parameters, hyperparameters used for training, fine tuning. These are my reference. Thank you. In conclusion, we developed a BioQA-BERT model using BioQA-BERT and Llama. The limitations, the data set need to expand the data set tomorrow. Now the data set contains 50,000 question and answer pairs. Need to expand it into more size. About the future work, this is only in health domain, need to expand it into a open domain. So integrate multimodal capabilities like audio processing, speech processing, and visual question answering kind of things. Then okay. Also extend to other languages too, multilingual languages. Thank you. These are my references.
So can you go to the methodology part, first methodology diagram? Okay. So how did you compute the top n documents from the vectors?
Sir, top n, here we choose top 10. We can change the number of documents in the function.
What metric you used for?
I didn't remember.
How many question answer pairs were collected for your data set?
Around 50,000.
Thank you.
What are the challenges you have faced when you are developing this bio-KPET model?
Sir, the lack of data set, we created the question answering data sets our own. It's take 1 year time. We manually process the data. After annotation also we done perform manually with the help of hashtag annotation tool.
What are the limitations of your bio-KPET model?
Data set.
What are the limitations of your model?
Need
What are the advantages of your model? You are proposing the hybrid model, right? You say some advantages, right? Then similarly, you have some limitations. What are the limitations of your model?
can be integrated with more accurate models, more LLMs models.
Similarly, nowadays, these batch models are evaluated using different performance metrics, right? So you are using the same precision, recall, effort score, but it is not actually advisable to evaluate these type of batch models. So you have to go look through that new metrics also. Okay. Okay, fine.
Thank you. In order to improve the accuracy of the performance of the model.
So did you do any comparison with the reader retriever architecture with the any other advanced architecture?
No.
No. You directly jump to reader retriever. So can you explain me like
I compare with the reader retriever without reader retriever. It's not included in this paper. It's included in my research work. This paper only include reader retriever.
what is the purpose of retriever in it?
Retrieve. It's all actually it is used in open domain question answering. The retriever job is to reduce the documents to a smaller set. Here we apply that technique. Thank you.
Thank you, Liji. Next, I invite Shruti Sarah Moses to present the paper Transfer Grammar Rules for Malayalam Verbs.
Okay, good evening, everyone. Welcome to this presentation titled Transfer Grammar Rules for Malayalam Verbs. My name is Shruti Sarah Moses, researcher in applied linguistics from Central University of Kerala, Kasaragod. And this paper has got Dr. Rajiv Arara and Dr. Davin L as its co-authors. So let's move on to this paper. So we know that machine translation has dramatically transformed how we use languages to connect globally. You know, it actually bridges the linguistic gaps. And nowadays, machine translation is not merely converting a text from one language to another. Nowadays, we use NMT, neural machine translation, powered by transformer-based architectures. We even fine-tune models for machine translation, and nowadays we use a multi-modal machine translation and all. So you will be frowning upon this particular title, Transfer Grammar Rules for Malayalam Verbs. So you will be wondering, in this era of transformer-based architectures, why am I using, or why are we using these transformer grammar rules for machine translation? The simple reason is that as a linguist, I can say that we cannot handle Malayalam as we handle any other languages in this world. We cannot handle the intricacies of this Malayalam as we handle any other European or even any other Indian languages. This is mainly because Malayalam is an agglutinative as well as morphologically rich language. So you will be wondering, what do you mean by this agglutination or morphological richness? So in Malayalam, new words are actually formed by this concatenation of morphemes to the root form of a Malayalam word. So I'll tell you one example. In English, we have got this construction, she might have been writing, and its Malayalam is aval ezhudukayirunirikkum. Okay, so in English we have she might have been writing. This is a very single construction, but when we look at it, we have got a tense in it, we have got an aspect in it. The word might indicates the aspect, I'm sorry, modality, and this has been indicates this tense and aspect. But all these inflections are not joined this with particular uh, lexical word writing when it comes to English. But when it comes to Malayalam, all these inflections are agglutinated or concatenated to this root form of the verb. That is, in this particular word, എഴുതുകയായിരുന്നിരിക്കും. Ezhudu will be the root word, and all these inflections will be added to this right side of this Malayalam root word. So that is why, as I said, we cannot handle Malayalam as we handle any other languages in this world. We can add on inflections to the right hand side of the Malayalam root word. എഴുതുകയായിരിക്കും, there can be another construction like എഴുതുകയായിരുന്നായതിനാൽ. So it can go on like that. So that's why Malayalam is known as a very complex, very agglutinative form of language. So that's why I made use of this transfer grammar, which is actually designed for transitioning between languages. And this paper specifically delves into the transfer grammar rules related to this Malayalam verbs. So this concept of transfer grammar was actually proposed by Zelling Harris. He's an American linguist in the year 1954, and he defined this as a set of specific rules for transferring from one language to another. He, in his paper, mentioned that we can even measure the difference between the grammatical structure of two different languages. So this is, I can explain this transfer grammar with this particular example. Consider A as a language with a particular set of utterances, and B as another language which is entirely different from A. So transfer grammar means what all changes can we do in this particular language A so that we can transform language A into language B. So it will be resulting in B minus A, which means that what is there in B that is over and above A. So this is actually the concept of transfer grammar, and the aim of this paper is to develop transfer grammar rules for Malayalam verbs, and it includes the tense, aspect and modality, and this can be made used in rule-based machine translation. So this is a simple methodology which I have used. So as I mentioned earlier, all these inflections are getting added to the root form of the Malayalam verb. But when we construct linguistic rules, if we are considering, adding morphemes or concatenating morphemes, the root form of the verb, it will sound awkward, or it will be very difficult for us. So for that, I have considered the uga form of the verb and its allomorphic variants are the skeleton on which every tense, aspect and modality operation starts from. I hope you have understood. I have taken the uga form of the Malayalam verb. Suppose if the verb is padi, paduga, chaduga, oduga, kareyuga. So all Malayalam verbs ending with uga. This uga forms of the Malayalam verbs are considered as a skeleton on which every operation starts from. And I'm also having a verb dictionary or a bilingual verb dictionary. And on the one hand, I will be having the first form of the verbs, first form of the English verbs like sing, dance, cry, laugh, first and form of the verbs. And on the other side, I will be having the corresponding uka form, corresponding Malayalam uka meaning of the verb. So suppose if the word is sing, in the dictionary I'll be having paduga as its Malayalam meaning. If the word is cry, I'll be having kariyuga as its Malayalam meaning. So I will be handling a bilingual verb dictionary for this purpose. So when we are giving an English verb, then it will be first POS tagged, we know that the sentence or this construction has been singing can be POS tagged as VBZ, VBN, and VBG. VBG, it's a gerund. Singing is a gerund. VBN means it's a past participle, and VBZ means it's a singular present tense. And after that, I'll be lemmatizing the main verb, that is singing. I'll be lemmatizing, and from that I will get sing as the lemma. And after that, I'll be fetching in the bilingual verb dictionary, like what is the corresponding uga form of the verb, English verb sing, and then I will get paduga from the bilingual verb dictionary. And after that, I will be doing the morpheme fixation. Like based on this combination of the POS tags, the further modification like addition or replacement or deletion of these elements will be done based on this combination of the POS tags. So here you can see that VBG is preceded by VBN, which is again preceded by VBZ. So this combination of POS tags shows that it's a progressive tense. And because since this is a progressive tense, I'll be having corresponding modifications or additions with regard to this. And after all these processes, I'll be I'll be jumping onto this morpheme fixation. So and then, I'll get this particular English word paduge ayirunnu as it's, I will be getting this particular Malayalam translation paduge ayirunnu for this English entry has been singing. So first, it will POS tag, it will find out the lemma. After that, it will fetch in the bilingual verb dictionary, and considering the combination of the POS tags, the further modification will be done on this uga part of the verb. So this is a past formation table. In English, we have got regular as well as irregular verbs. In English, we have play, played, or sing, sang. It will be either regular or irregular form of verbs. But when it comes to Malayalam, Malayalam has got lots and lots of tense markers. Handling past tense in Malayalam is not a simple task. It's a very Herculean task. So in this paper, I have listed out more than 20 kinds of past tense markers in Malayalam. You can see e, chu, nu, nu, ti. These are on the right hand side. You can see the list of past tense markers, and on the left hand side, you can see the uga and its various allomorphic variants. So when past tense entry is coming, this uga or its allomorphic variants will be removed, and it will be substituted by this particular past endings. I need to tell you that this is not a complete list. Even there are certain exceptional cases, and more than 20 or 25 kinds of past tense endings are there in Malayalam verbs. So when I used this particular kind of approach in RBMT, it was found that it showed an accuracy of 60%. But since as a first level, I have considered only the simple constructions or simple sentences, and I haven't gone to this compounding of verbs or very complex verb structures. So this is what my paper is. So in this paper, I have developed the transfer grammar rules for Malayalam verbs. And as a linguist, I can say that even if you are building so much transformer models, I'm damn sure that these models cannot always, they cannot give you the correct human-like machine translation, because in linguistics, we say that human constructions are unpredictable. Okay, nobody can predict how complex a linguistic construction will be. Human constructions are always unpredictable, no matter what the language is. So when it comes to Malayalam, it will be more and more complex, because we know the structure of Malayalam. We know Malayalam is the most difficult language in the world. Even a Malayali child, when you look at what she or he is saying, you can, you will get to know that even if she or he hasn't even heard about that particular word in his lifetime, he utters that. We will never know from where this child got this particular word. So that's why I said in any language, this human constructions are unpredictable. So there are chances where this transformer based models may fail when it comes to these very complex language or complex verb structures. So that's why I made use of this transfer grammar roots for machine translation. Okay, that's it. Thank you.
Any question from audience? Anybody?
Can you take the block diagram? Okay, like how did you execute this thing?
So when there is a word, so has been singing can be considered as a single construction. It will be.
You manually wrote down the whole thing.
Sorry, you manually?
Like from English verb, you will be manually writing down the POS tag. Then you will be lemmatizing the thing.
I didn't get you.
Like you did it manually, or you have some kind of automated thing to analyze the structure.
No, this was done manually.
This was done manually. So how many number of verbs did you try out?
How many number of verbs?
Yes,
so
sir.
this particular methodology or workflow is applicable for simple present tense, past tense, including the aspect and modality. Simple sentences or simple verbs, not complex verbs.
Still, I think it's only verbs that you are specifying, right? There is no
Yes.
sentence.
No sentence.
So, like, what kind of thing that you are comparing with to get an accuracy?
What
Like
verb?
you know exactly what kind of verbs work for the system, right? Like you have a form has been singing, and you know that it after lemma it will turn to bilingual paduga, and then you have written the rule for the same thing, right? So you know exactly that it will not work for another thing, right?
No, I didn't get you. You will?
Like has been singing, you know that has been singing transforms to something. Exactly, and you have written the rule for exactly that. And so when you exactly know how the transformation happens, like how will we get the accuracy? What kind of metric that we are measuring to get the accuracy?
See,
What are we comparing it to?
See, when I implemented this kind of approach in machine translation, I got 60% accuracy. That's what I said.
Like you are giving a rule, right?
Yes, this was part of my MA thesis, and this was done for handling Malayalam verbs.
Exactly. So when you are giving a rule, when you are proposing a rule, like how are we? What are we comparing it to get an accuracy? Because it will work for that rule, right?
Yes.
So what are we comparing to get an accuracy?
So this was compared to this human translation.
So you are comparing your rule to human translation, and number of verbs used for that.
Um,
For calculating the accuracy.
A list of 100 sentences were used.
No, the rule is for verbs, right?
Yes.
So we are not discussing about sentences, right? So only verbs, right?
See, I said this was a part of my thesis, and this is what I used for handling verbs.
Yes, of course. So you have mentioned something regarding rules for verbs. So the question is that what are we comparing it to get an accuracy for?
I compared it with human translation.
Only verbs.
Yes.
So I asked the particular number that we compared it with. Number of verbs that humans translated, and number of verbs
100.
this is 100. Yes, sir. Yes. Yes.
Uga,
Yes.
then in Chirikua, there is a Uga is emanating that Uka.
Yes.
Chirikua, Harayunu, you is adding there, you.
Yes, of course.
Likewise, there's particular things she has given a transgram in that positions, in that position. They are getting it. In the, that there she has made another approach there for each and every word. each and every verb in the sense, the transfer is there, only particular point of making tenses. Only that tenses will making changes. In that cases, she has made another approach in the sense. No, they all the in here she has been done that verb itself is making changes in vevuga is changing to vendu, not vevikkunnu kuva.
Exactly.
In the
Vevuga will only change to Vandu.
vendu
And that rule
novuga
that will,
nondu novuga
that place the rule will always work. Right?
that type of rule she has made for the verbs.
Yes. So it will always give 100% accuracy, right? Because for that rule it will always give a correct answer, right?
That is why I'm saying that chirikua ka is coming now.
Yes.
Chirichu.
Yes.
Chu is chirikua. Chu is coming
But
for
different
past tense.
rules, right?
Then karayuga.
Yes.
Karanyu.
Yes, of
This
course.
type of change is coming. Wherever this type of change is coming, she has made a rule.
Exactly. So that rule always follows that Chirikuga will always follow a rule. Right?
She has taken only 100. That is why 60%.
So out of 100, like 60 words, verbs
Not
will
but
get, will get a
in the
correct answer.
sentence, 60%.
No, in the not sentence. Sir.
Yeah. Then she is not taken like that. Only only the 100 sentence. Within the 100 sentence, there is a particular space is there, and for only the 100 sentences only. Now that yeah. It is.
So, like my point was, when we have a rule, it actually works for that exact rule, right? Not for general. Just we'll take for the verb.
Started to trying.
Yes, sir. We'll take the verb, and it will always perform for the rule, right?
Yeah.
So it will always work for that rule.
Yeah.
So there is not a problem with the accuracy. We'll be getting a perfect answer every time.
Perfect answer should be there, but she has been done only for the 100 sentence only. She has been taken. If she has been taken more sentences and generalize it, then it should be a proper
then
one.
the problem comes with how many actual number of different cases are there. Then we have to compare with the whole number of cases and then take the accuracy, right?
Then it has to be made a general rule. Otherwise, now it cannot be as a general rule.
So, like, what kind of metric we are comparing with? Still, we are getting a 60% accuracy. That
Only by 100 sentences. In that sentence only that she can get the 60%, not from the other.
okay. So the point, what I was trying to make clear is that, like, when we have a perfect rule, it'll for the specific word.
If we are saying 60, there is huge high level 60. If it is general one.
Yeah.
But
in this specific one, she'll be getting an accurate.
Only her 100 sentence.
Yes.
Only her 100. If you are provide another 100, it don't work.
Exactly. So in those 100 sentences, it will work perfectly, right? Whatever we are considered the rules.
That is also working 60%.
Okay. Thank you.
That problem is there.
Okay. Okay.
Because she has done it in the embed level.
Okay.
We have two more.
Okay. Thank you. Thank you.
Thank
you.